Hey, you. Ever found yourself facing a problem, maybe thinking, there are like 5 different ways I could solve this, and just wishing you could pick the absolute best one right at the last second?
Oh, absolutely. That feeling, it hits a lot of developers. And it really gets to the heart of why these things called behavioral design patterns are so useful.
Behavioral design patterns.
Okay. Yeah, think of them as like proven blueprints, ways to make sure different software parts can interact smoothly, especially when things get complicated. It's all about how objects and classes talk to each other and, share the work.
Okay, interesting. So let's unpack this a bit. Today, we're doing a deep dive into one specific pattern, the strategy pattern.
Sounds tactical.
It kind of is. The
Yep.
core idea, basically, is you've got multiple ways, algorithms, to do the same job.
Right.
But the really cool part is deciding which way to use isn't fixed. You can make that choice while the program is actually running, at runtime.
While it's running, not beforehand.
Exactly. We're separating the what needs doing from the specific how it gets done. Okay. So it's like having, different tools in your toolbox, a wrench, pliers, a socket. They all tighten bolts, but you only pick which one when you see the actual bolt you need to tighten.
That's a great analogy. Yeah. And to make that work, each different method, each tool is kept nice and tidy in its own separate class.
Keeps things clean.
Totally. It makes swapping one approach for another much easier without, messing up the whole structure.
Sounds like a potential lifesaver, especially when requirements inevitably change. So, how would this actually look in a real software project?
Okay, let's take a common scenario.
Yeah.
Imagine a tourism agency, right? They sell travel packages online.
Yep, booked a few myself.
So they need to handle payments. But customers, they want options.
Yep.
Credit card, maybe cash if it's last minute, PayPal.
Yeah, definitely want choices there.
Exactly. So the agency software needs a payment system that's flexible enough for all that, but doesn't become this huge tangled mess of if this, then that code.
Right. Avoid the spaghetti code.
Precisely. And this is where the strategy pattern comes in handy. The key insight is that the main part of the system handling the payment doesn't actually need to know the specifics of how a credit card payment works versus a PayPal one.
Okay, so it needs flexibility. How does the pattern give us that? What are the main parts involved? The participants.
Good question. There are a few key players. First, there's something often called iStrategy. Our source sometimes calls it Mod Plata, but let's stick with iStrategy. Think of it as the contract, an interface, or maybe an abstract class.
Like a blueprint.
Exactly. A blueprint, it defines the common steps or methods that all the different payment methods will have to follow. Like maybe they all need a process payment method.
So iStrategy says you need to be able to process a payment, but doesn't say how for each specific type.
Correct. Then you have the actual specific ways, the concrete strategies. These are classes like cash payment, card payment, PayPal payment.
The implementations.
Right. Each one is a separate class, and each one implements that iStrategy blueprint, but does the payment processing in its own unique way. Card payment knows about card numbers and expiry dates. PayPal payment knows how to talk to the PayPal API, and so on.
Got it. So cash knows cash, card knows cards, PayPal knows PayPal. What's the piece that actually uses these strategies?
That's usually called the context. The source material mentions object or client. Let's mostly use client here. This is the class, maybe the main shopping cart or booking system that needs the payment processed.
Okay.
It holds a reference, like a variable, that points to an iStrategy object. But here's the important part. The client doesn't necessarily know or care if that variable is currently pointing to a cash payment object, a card payment object, or PayPal payment. It just knows it has something that can process a payment according to that iStrategy contract.
Okay, so the client has like a slot.
Yeah.
And it can plug in any of the payment strategies.
Yeah.
Cash, card, PayPal, whatever fits the iStrategy shape.
You got it. That's the core idea.
So how does that work in practice? When I, the customer, actually click pay.
Right. So the elegance is in how it's set up. Inside each concrete strategy class, cash, card, PayPal, you have the actual code to do the work for that method.
The nitty-gritty details.
Exactly. Now, the client class needs a way to figure out which strategy object to use at a given moment. Maybe the user clicks a Pay with PayPal button on the website.
Okay.
That click tells the client object, okay, set your current payment strategy to be the PayPal payment one. So the client updates its internal reference to point to the PayPal payment object.
Mm-hmm.
Then, when it's actually time to process the payment amount, the client just calls the process payment method on whatever strategy object it's currently holding. It doesn't need a big if statement.
So the client just says effectively, hey, payment strategy, whoever you are, process this payment. And the specific cash or card or PayPal object handled it.
That's it, exactly. The client is decoupled. It's not tightly bound to the specifics of any single payment method. It only cares about the iStrategy interface.
Wow. Okay, that sounds incredibly flexible.
It is. And think about the future. If the agency wants to add, say, crypto payments later, they just create a new crypto payment class that implements a strategy. The existing client card barely needs to change, maybe just the part where the user selects the option. It can just start using the new strategy.
That makes a ton of sense. Avoids that massive block of conditional logic that gets harder and harder to manage over time.
Right. Keeps the code cleaner, much more maintainable.
So the source mentioned other places this pattern is useful beyond just payments. What are some other examples? Where else is this kind of algorithm swapping powerful?
Yeah, definitely. Sorting is a classic example mentioned. Imagine you have a list of things. Sometimes you need to sort them alphabetically, other times maybe by date or by size.
Okay, yeah, different sorting needs.
With the strategy pattern, you can define each comparison method comparing by name, comparing by date as its own separate strategy class. The main sorting algorithm, which acts as the client, can then just be given whichever comparison strategy it needs at runtime.
So the sorting logic itself stays the same. It just uses a different rule for comparing items provided by the strategy, like a sort by date strategy or sort by name strategy.
Exactly. You plug in the comparison rule you need. Another really common one is input validation.
Oh yeah, validating forms and stuff.
Right. The rules for a valid email address are totally different from the rules for a valid phone number or maybe a postal code.
True.
So you can create separate validator strategy classes, email validator, phone validator, each implementing a common iValidator interface. Then the part of your code that needs to check the data of the client just picks the right validator strategy based on what kind of data it's looking at.
That's really smart. Keeps all that specific validation logic nicely separated and reusable. Okay, now the source also mentioned another pattern, state, and said it's kind of similar to strategy sometimes. What's the key difference there?
Yes. That's a really important distinction to make. They both involve changing an object's behavior, which can look similar from the outside, but how that change happens is different.
How so?
With the strategy pattern, the specific strategy to use is usually given to the client from outside. Maybe it's passed in as a parameter when you call a method or set through a configuration step. The client often knows it has different strategies available and chooses one or is told which one to use.
Okay, so the choice is sort of injected from the outside in strategy. What about state?
In the state pattern, the change in behavior is typically driven by the object's own internal state. Think of an object moving through different phases or modes. When an event happens, the object might transition from one state to another, and that new state dictates its new behavior. The object itself often manages these transitions.
Okay. So strategy is like picking an external tool for the job, but state is more like the object itself changing its internal mode or configuration based on what's happened to it, like a traffic light changing from green to yellow to red.
That's a great way to put it. The traffic light's behavior, showing green, yellow, or red light, is determined by its internal state, and it transitions between states based on timers or external triggers. With strategy, the client is more actively configured with a specific way of doing something.
So when would you pick state, even if the outcome seems similar?
You lean towards state when the object naturally progresses through distinct stages, and its behavior is fundamentally tied to which stage it's currently in. The transitions between these stages are often part of the object's own logic. Strategy is better when you have a family of algorithms that are largely independent of the client's internal state, and you just want to select one to perform a specific task.
Got it. The control mechanism is the key difference. Strategy is external selection. State is internal state driving behavior.
Exactly. The context in strategy uses a strategy. The context is in a state in the state pattern.
Okay, that clears things up. Now, the source had one more concrete example for strategy, right? Something at a hotel check-in.
Yes, a good practical one. Imagine a hotel receptionist checking in guests. The document verification process changes depending on the guest's origin.
Right. Different rules for different people.
So if it's an EU citizen traveling within the EU, they check and scan the national ID card. If it's an EU citizen arriving from outside the EU, they need to check and scan the passport.
Okay.
And if it's, say, an American citizen, the process involves checking and scanning their visa along with their passport.
So 3 distinct procedures.
Yeah.
And the receptionist or the check-in system needs to apply the correct one based on who just walked up.
Exactly. The right verification method is chosen right then and there at runtime. It's perfect for strategy.
How would you model that?
You define an I strategy, maybe call it verification strategy. It would outline the basic steps like verify document and scan document.
The blueprint again?
Yep. Then you create concrete strategies. EU internal verification, EU passport verification, US visa verification. Each one implements the verification strategy interface but contains the specific logic for handling the required documents and steps.
And the client here would be the hotel's check-in software.
Exactly. The software identifies the guest's nationality, maybe from the booking info or by asking. Then it selects the corresponding verification strategy object, EU internal verification, US visa verification, whatever fits. And then it just calls the verify document and scan document methods on that chosen strategy object. No big chain of if-else, if-else.
Yeah, much cleaner, much more adaptable if, say, they need to add rules for Canadian citizens later.
Yeah.
Just add a Canadian verification strategy.
Precisely. Add the new strategy, update the selection logic, and the core check-in process doesn't need a major overhaul.
That really drives home the benefit. Okay, so wrapping this up for our listeners, what's the main takeaway, the core advantage of using the strategy pattern?
I'd say the number one benefit is flexibility. It lets you define a family of algorithms, put each one in its own class, and make them interchangeable. You can choose which algorithm to use at the last possible moment, runtime.
Decoupling the what's from the how.
Exactly. It avoids locking your main code into one specific implementation. This makes your software way more adaptable to changes, easier to maintain, and easier to extend down the road. You're basically designing for change by keeping things separate.
Makes a lot of sense. All right, so a final thought for everyone listening. Think about challenges you face, maybe at work, maybe just everyday stuff. Are there tasks where you have different ways to approach them, and the best way depends on the situation?
Yeah.
Consider how this idea, having interchangeable strategies you can select on the fly, might apply. What problems could that kind of flexibility help you solve, maybe in ways you haven't thought of before? Where else could swapping out the how be really powerful?